Hello my dear children, I hope you are doing well. Today we will be studying about measures of central tendency. There are different types of data and on the basis of that data there are different type of formulas that we use to measure the arithmetic mean. Let's start. So central tendency means a central value used to represent huge data within a single numerical value. This central tendency is also known as average. The key features of central tendency are as follows. It provides a brief description of huge raw data. It helps in comparing data. It helps in making decisions. It is used to perform statistical analysis. A single value represents a huge data set. The measures of central tendency are mean, median and mode. In this video, we will be focusing only on the first type of measure of central tendency, which is the mean. Mean is also known as arithmetic mean. It is a sum of all observations divided by the number of observations. It is denoted by x dash. So here we take all the observations, add them and divide them by the number of observations. So we get sigma x by n, where x1 represents the individual observations. Sigma x signifies the total of all the observations and n stands for the total number of observations. Next is the calculation of arithmetic mean. We have three types of data: individual data, ungrouped data and group data. Individual data can be measured with three methods: direct, assume mean and step deviation method. Ungrouped data is discrete series, direct method, assume mean method also called shortcut method and step deviation method. Last is group data, we call them continuous series. Here also we have three methods: direct method, assume mean method and step deviation method. Please note, assume mean method is nothing but the shortcut method. So let's start with the individual data, direct method. Here we have different observations given and the formula here says x bar is equal to sigma x by n. N here means the number of observations, so we are going to count the number of observations. So 5, 10, 10, 12, when we count all of them we get 10. Now we are going to add all the observations, and when we add all the observation we get sigma x. Sigma x is the sum of all individual values, so it comes equal to 158. So the direct formula is sigma x by n. You can see 158 divided by 10, we get the arithmetic mean as 15.8. Following the direct method is the assumed mean method, also known as shortcut method. The formula here is x bar is equal to a plus sigma d by n, where a stands for the arithmetic assumed mean, x is the individual observations, n are the total number of observations and d is the deviation of the assumed mean, where d is equal to x minus a. So in this case we have assumed a to be 15. So 5 minus 15 will be minus 10. You can see on the left hand side corner there are two boxes, x observations given, and from x we are calculating the deviation. So 5 minus 15 is minus 10, 10 minus 15 is minus 5, again 10 minus 15 is minus 5, 12 minus 15 is minus 3, 15 minus 15 is 0. Now the values will be positive because the number of x is more than 15. 18 minus 15 is 3, 20 minus 15 is 5, 21 minus 15 is 6, 22 minus 15 is 7 and 25 minus 15 is 10. So we are going to add the deviation that we have calculated. So the sum of the deviation is equal to 8. Now we are going to insert all the values in the given formula. 15 was the assumed mean. The sigma d is 8 and number of observations are 10. So 15 plus 8 by 10 is equal to 15.A, which is the arithmetic mean calculated by the assumed mean method, also called shortcut method. This was all about the individual data. Let's proceed to the ungrouped data, which is the discrete series. Here we are going to get the observations along with the frequency. But in the individual data we did not get frequency, we only got the observations. But in this type of questions, observations and the frequencies will be given together. So the question says there are different observations given. So number of observations are given. Then we have the number of students, which is the frequency. We will calculate the deviation from the assumed mean. Assumed mean here also is 15. So from 15 we are going to minus the value given at x. So 25 minus 15 is 10. 15 minus 15 is 0. 10 minus 15 is minus 5. 5 minus 15 is minus 10. And so on, we are going to calculate for all the observations. Now, whatever was the value of the number of students, which was the frequency, now we need to multiply that with the deviation that we have calculated just now. Now we will get f into d. So frequency is 3, deviation is 10, 3 into 10 is 30, then 3 into 0 is 0, 2 into minus 5 is minus 10, 1 into minus 10 is minus 10, 6 into 3 is 18, 5 into 6 is 30, 3 into 5 is 15, 2 into 7 is 14, 3 into minus 3 is minus 9. After this we are going to add all the values of fd and get sigma fd, which is given as 78, and also we are going to add the values of the frequency, which we have got 28. After receiving all the values, so A is 15, sigma fd is 78, sigma f is 28. So when we put the values in the formula A plus sigma fd by sigma f, we get the arithmetic mean as 17.8. Next is the step deviation method under the discrete series, or we also call it ungrouped data. Here the values are going to remain the same as we have calculated in the previous question. The only difference here, you can see two columns being added. One is d dash, whatever deviation we have calculated, that divided by c. And next is f into d dash, frequency into the value whatever we have calculated at d dash, we are going to multiply. After multiplying, we are going to get sigma fd dash, and sigma f we already calculated. We'll insert the values in the formula, which says x bar is equal to a plus sigma fd dash by sigma f into c. C here is the common factor of deviation in each of the frequency. So a is 15, c is 1, sigma fd dash is 78, sigma f is 28. We get the same mean as we have calculated under the shortcut method as 17.8. Group data and direct method. Group data is also known as continuous series. Continuous series is nothing but the class intervals which are given. Along with that, the observations here become the frequency. We have the mid value, which is denoted by letter m, which is nothing but the lower class interval plus the upper class interval divided by 2. So 0 plus 10 divided by 2 is 5. And when we multiply the frequency and the mid value, we get fm. So the formula here says in the direct method, mean is equal to sigma fm by sigma f, where f is each frequency, m is the mid value for each class. We total the values of Fm together. Like in this case, we have got 7660. We also add all the frequencies together and we get sigma F. In this case, it is 158. We put these values in the given formula and derive mean as 48.48. The next method here is assumed mean, also known as shortcut method. So the class intervals are the same. Observations are given as frequency. Mid value we will calculate. And the most important here is the deviation, which is m minus a. In case of discrete series, we were taking it as x minus a. A stands for assumed mean. Sigma f, we are going to add all the frequencies together and we are going to get sigma f, which is equal to 158. A is the assumed mean. So 5 minus 15 is minus 10. 15 minus 15 is 0. 25 minus 15 is 10. So like that, for all the values we are going to calculate the deviation. After the deviation, we are going to multiply the frequency and the deviation together and we are going to get FD. We are going to calculate all the values of FD, add them together and get sigma FD. Sigma FD is 5290. Sigma F is 158. We are going to put the values in the given formula. A plus sigma FD by sigma F. 15 plus 5290 divided by 158. So the mean is 48.48. The last method is the step deviation method. As in the case of discrete series, we had calculated deviation dash. In the same way, here also we are going to calculate the deviation dash, which is the deviation that we have got divided by the class interval. So here in this case it is 10. So whatever deviation we have got, minus 10 divided by 10 is minus 1. 0 divided by 10 is 0. 10 divided by 10 is 1. 20 divided by 10 is 2. And so on and so forth. Then we are going to multiply the frequency and the d dash and get fd dash. Like 25 into minus 1 is minus 25. 15 into 0 is 0. 10 into 1 is 10. 5 into 2 is 10. 18 into 3 is 54. 21 into 4 is 84. 20 into 5 is 100. 22 into 6 is 132. 12 into 7 is 84. 10 into 8 is 80. After getting all the values, we are going to total them up and get sigma fd dash, which is equal to 529. Now put all the values in the formula. A plus sigma fd dash by sigma f into c, where a is the assumed mean, f is the frequency, c is the common factor of deviation, d dash is d by c, and m is the mid value. So 15 plus 529 divided by 158 multiplied by 10 is equal to 48.48. The demerits of arithmetic mean. The extreme values which we get by calculating the arithmetic mean, they get distorted by extreme values of the series. The mean value may not occur in all the series at all. For example, 12, 13 and 17. The mean value is 14, which is not present at all. Laughable conclusions. A mean value of 21.5 candidates is not meaningful because there cannot be a half a candidate. Unsuitability. The arithmetic mean is not suitable measure in case of percentage or proportionate values. It sometimes misleads conclusions. Let's compare the marks secured by X and Y in semester 1, then semester 2, then semester 3. If we calculate the average secured by X and Y, the average is the same. But can you notice some difference? As compared to X, Y's marks are decreasing per semester. But in case of X, They are increasing per semester, but the averages remain the same. The next topic is weighted arithmetic mean. When different items of a series are weighted according to their relative importance, the average of these series is known as weighted arithmetic average, denoted by Wm. The formula is sigma Wx by sigma W, where W stands for weights and X is the observations. So there are marks given, weights are also given. We multiply X into W and get Wx. When we total Wx, we get sigma Wx. When we total W, we get sigma W. We put the values in the given formula, where is arithmetic mean is equal to sigma Wx by sigma W. So 290 by 11. As per the formula, weighted arithmetic mean is 26.4.